Alrighty, so this is example 3, part B. So our function is -2 sine of 1/2 theta. So we're supposed to find the amplitude, the period, and sketch the graph. So I'm going to go ahead and fill in some information here first. Let's go ahead and do the amplitude. So remember, the amplitude is always positive. So in this case, the amplitude equals to the absolute value of -2, which is just 2. So this is going to be vertically shifted by 2, or not vertically shifted, vertically stretched by 2 units. All right. Also, our new period is going to be 2 pi over k, and k in this case is 1/2. Okay, so we end up with multiplying by 2 over 1, and we do that to the top also. The bottom cancels out. We end up with 2 pi times 2, and that ends up with 4 pi over 1, which is 4 pi. So this graph is going to complete a cycle from 0 to 4 pi instead of to 2 pi. So you're going to see the graph of sine be kind of shrunken in between 0 to 2 pi, and then we'll see the whole graph, -2 sine of 1/2 theta, between 0 and 4 pi. So right now, I'm going to go ahead and fill in what I need. 1, 2, 3, 4, 5, 6, 7. I believe I need 8 for this one. 1, 2, 3, 4, 5, 6, 7. Maybe not. Yeah, no, I'm good. All right, so from here, we have our normal 0, pi over 2, just like our regular cycle, pi, 3 pi over 2, and 2 pi. Oops, you write that nicely. All right, we aren't going to need these two for now. Because again, this is the regular graph for sine goes from 0 to 2 pi. Now in this case, we are going to have 4 graphs. It's going to be sine theta. We're going to have sine of 1/2 theta. That looks horrible, but that's 1 over 2. And then we're going to have 2 sine of 1/2 theta. For the last one, I'm going to put just prime here because we're going to use these numbers to insert into these. And then for our fourth one, we're going to have, it should be a 2. So that's -2 sine of 1/2 theta. And again, we insert from 0 to 4 pi. So those are our 4 graphs that we're going to take a look at. So let us look at now for 0 to 4 pi, we're going to be plugging in 0, pi. So I'm going to skip this one. 2 pi, 3 pi, and 4 pi. Because again, there's a 4 quadrants, so we start from 0 at the beginning, then we go to 1 quadrant, which is pi, then the second quadrant, which is 2 pi, third quadrant, 3 pi, fourth quadrant, 4 pi, because again, this period completes a cycle between 0 and 4 pi and not 2 pi. So for sine of regular theta, we're just going to be filling out the normal one. So for sine of 0, we get 0. For sine of pi over 2, we get 1. Sine of pi, we get 0. Sine of 3 pi over 2 is -1. And then sine of 2 pi is 0. Now for these, we don't need 3 pi or 4 pi because again, sine, the normal sine graph completes a cycle between 0 and 2 pi. Now for this one, we're going to be using the new period. So for this, we're going to be inserting these numbers into it. So for sine of 1/2 theta prime, that means sine of 1/2 0, that's going to be 0. For sine of 1/2 of pi over 2, well, that's not relevant because it's not existent. It does exist, but we want to just get the main numbers from each quadrant. So we skip over to pi. So we're not going to use this one. So the next number, sine of 1/2 of pi, is going to be 1 because, again, this one it has the same values as the sine graph does, okay? But again, it's between 0 and 4 pi instead of being 0 to 2 pi, okay? So we're going to go 0, not relevant, pi. 3 pi over 2, again, is not one of the quadrants for sine of 1/2 theta. Sine of 1/2 of 2 pi is going to play the 0 role. Sine of 1/2 of 3 pi now is going to be -1. And then finally, sine of 1/2 of 4 pi is going to be 0. So notice how these match, only that these pi over 2 and 3 pi over 2 aren't relevant. So we're just using 0, pi, 2 pi, 3 pi, and 4 pi. Okay. All right. And now for 2 sine of 1/2 theta prime, we're going to be filling in, again, using these values here. But all this means here is that we're multiplying each of these by 2 because the amplitude, again, is a vertical stretch. So all we're going to do is multiply by 2, we get 0. This is not relevant. Multiply by 2, we get 2. Again, not relevant at 3 pi over 2. So we go to 2 pi, multiply by 2, we get 0. We go to 3 pi, multiply by 2, we get -2. And we go to 4 pi, multiply by 2, and we get 0. So 0, 2, 0, -2, 0. And again, these spaces represent the pi over 2 and the 3 pi over 2, which is, again, not the main quadrant for this new graph, okay? All right, and finally, the only thing is this negative. That's a reflection across the x-axis, right? So we're going to reflect. So that represents a reflection across x-axis. Okay, so here we're going to go ahead and basically multiply all of these by -1. So I'm going to multiply by -1, multiply by -1, multiply by -1. Same with the last two. Because it reflects it across the x-axis, we end up with 0. This one's not relevant. -2, not relevant. 0. And then -2 times -1 is +2. And then 0 times -1 is just 0. So these are the ones for our final graph of -2 sine of 1/2 theta. So like before, bear with me. I'm going to take a snip of this graph. And I'm going to bring it to the next slide. And I need to get a graph from somewhere, so bear with me. Let me copy this. All right. All right, I guess that will do. All right, so let's take a look then at the graph. So this is going to be 1, 2, 3, and 4. This is -1, oops, -2, -3, -4. All right, and then again, we go from 0 to 4 pi. So we got 0 here. This next number is going to be pi. And then we have 2 pi. And then we have 3 pi. And then we have 4 pi. Oops, wrong place. 4 pi is over here. Four pi. All right. And if you wanted to, you could put here and here, just for the sake of like where knowing things are. This value here is again pi over 2. That would be this one. And this one is 3 pi over 2. So you can put it in there if you want, just, to keep track of like from 0 to 2 pi is going to be this one here that we're going to graph with the original number. So that way maybe it doesn't throw you off. And then for the rest of them, that's going to be all the rest of the values. So that would be sine of 1/2 theta, 2 sine of 1/2 theta, and negative 2 sine of 1/2 theta. And again, I'll be using 4 different colors here. I'm going to go ahead and graph this blue one first. So at 0, it's 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's negative 1. And then back at 2 pi, it's 0. So here is the graph of sine. Notice how it's small compared to what we've been doing before. So this is sine theta. All right, and our next graph, sine of 1/2 theta. Again, all that is going to do is going to treat everything the same, but it's going to horizontally stretch the sine graph between 0 to 4 pi. So you're going to see exactly the same graph, but it's going to be stretched out between 0 to 4 pi. So I'm going to use a different color. I believe I'm going to use this zombie green again, and then I'll go to probably orange or something like that. So, all right. So for our next graph, we're going to go ahead and graph sine of 1/2 theta. So at 0, it's 0. At pi, it is 1. Excuse me. At 2 pi here, it is 0. At 3 pi, it is negative 1. And then at 4 pi, it is 0. And I should have highlighted that so you know what numbers I'm looking at. So I'm using the zombie green color right there. And notice this looks exactly like the regular sine graph that we do. Let me do that again. But again, it's horizontally stretched between 0 and 4 pi. So that one is going to be the sine of 1/2 theta. Okay. All right. The next color I'll use is, I guess, an orange color. I don't know if that'll be prominent enough, but we'll try it out. Okay. So this one's going to be orange. All right. So again, at 0, it's 0. So for this one, remember the amplitude is 2. So this is a vertical stretch by 2 units. So at 0, it's 0. At pi, it is 2. So 1, 2, that's up here. At 2 pi, it's back to 0. At 3 pi, it's at negative 2, 1, 2. And then at 4 pi, it's back to 0. So there we got the amplitude of 2. It's a little off right there, but you kind of get the point. I mean, let me see. That made it look worse. So I'll just leave it like that. So I'm going to go ahead and put 2 sine of 1/2 theta. Okay, and then lastly, which I'll do in red, is negative 2 sine of 1/2 theta. That one negative, all it's going to do is take the orange one and treat the x-axis like it were a mirror. So like this point will go down here, that will stay there. At 0, it will stay there. At 3 pi, this value here is going to go up here. across the x-axis, and then that will stay there. So at 0, it's still 0. At pi, it's going to be -2. At 2 pi, it's going to be 0. At 3 pi, it's going to be +2. And then at 0, it's 0. So there is our graph. Ooh, that one came out nice. Nice. All right, something good at least this week. So -2 sine of 1/2 theta. And there are our 4 graphs for this one. Again, I'm trying to give you perspective of what the graphs transformations do, just to kind of give you a little bit of insight there. So I'm going to, again, stop the video. I'm going to post it on YouTube as example 3B. I'm going to post the first one, obviously, example 3A. And I'm going to do now the last example for this section, which I feel like it's a lot for one day, for tomorrow, for you to look at, maybe during class, and complete the worksheet. And that way you can finish up the homework for 4.5. So I'll repeat that on the next video. So I'm going to go ahead and stop it now, and I will see you on the next video.